Hello again YouTube. Today I'm going to have a look at some LED lights. I'm trying to improve the lighting on the bench so that when I'm filming things are well lit, and you might be able to see from the video that there's some flicker on the video from the light source. Now that's just coming from the mains, coming from the AC frequency. So I've got 3 sets of lights over my bench at the moment, so I'll turn them off in series and see where the flicker's coming from. So I've got 2 spotlights at the top. I've turned those off. There's still a little bit of flicker, so I'll put those back on. I've then got 3 downlights, and they're actually 2 are incandescent lights and one's an LED light. If I turn those off, you can see quite a lot of the light disappears, and most of the flicker, I think all the flicker's away. And then I've got an LED bar, so I've got a shelf up here, and underneath it I've got an LED bar right above the bench, and you can see that makes quite a bit of difference to the level of light. And there's not much flicker, but I think most of the flicker is coming from these downlights above the bench. So to try and improve the situation, I bought 2 of these. So these have come from B&Q. They're colours. You see, this is one of the issues I have when I bring anything up towards the phone camera. I'm using a Samsung Galaxy phone as a camera, so when I bring anything up close I've got a dark spot. But bring another battery powered light in here. There you go. So it's a B&Q Colours LED light, and you can probably see now that we've got a white background here, the flicker's quite obvious, and it's getting worse. That's what I need to get rid of. So I'm gonna use these, because these are heavily diffused panels. Now what these are is, it's a plastic layer in here. There's actually 3 or 4 plastic layers, and the LEDs are LED tape that goes around the outside. The light shines in the way, and then it gets diffused and comes out the front. They're 17.5 watts, and it's a 30, I think it's a 30 volt, 30 volt DC power source. Now, because it's quite specific, they come obviously with their own LED driver. So I bought 2 of these, and I'm going to show you how they are as they come out of the box. So I'll put all the other light sources off, and you can see there's a very heavy flicker coming from this, so that's obviously not going to improve the situation any. And straight away, as soon as I turn it off, that goes off. So that's it's quite a well designed little unit. The flicker's it's not visible to the naked eye. Obviously the shutter speed of the camera reacts with it, and that makes a significant difference. This is a second LED driver. I've bought 2 of the units, so I've already been experimenting with this one to try and improve the results. Now at first I used some capacitors, and I had some lying about, so I used this one first. It's 1000 microfarad 50 volt, and then I had this one again. I had this lying about. This is a 2200 microfarad 50 volts. I tried those in one each, and each time this one improved it, but the flicker was still quite visible. This one almost eliminated the flicker, but not quite. So I didn't have any more capacitors lying about to play with, so I ordered some and I bought these. So these are the 2200 microfarad at 50 volt, and I've put 2 of these in parallel here to try and increase the capacitance. We'll see what difference that makes. Okay, so that's the the product looking directly at it. As you can see, there's very, very little. Flicker's barely perceptible. And if we look at the bench indirectly lit by it, this is just one panel, just all the other light sources are off, and that looks pretty smooth. So if there is any flicker left, I certainly can't see it. It's not perceptible to the naked eye, and it certainly appears to be imperceptible to the camera. So there's a couple of things I need to look at here. First, now just switch this off. So if you watch it when it powers down, so I'm switching it off now, and you can see that it glows for quite a while after it's been powered down. Now the reason for that is I've increased the capacitance on the output from the power supply quite significantly. So it's taken, you can still see the outline of my hand on there, it's taken quite a long time to die, and although the camera can't pick up the glow anymore, it actually is still glowing, so there is still some voltage seeping out now through the LEDs. It'll get to a point as well where the LEDs don't pass any current, and won't pass any current because the voltage source has dropped below the forward pass voltage of the LEDs. Now this power supply here does have a little bleed resistor in the power supply. The way the bleed resistors are calculated is you take the load and the supply, you then take the capacitance of the biggest capacitor, or the combined capacitance of the whole circuit, and you then work out how long you want it to bleed over. So you would want it, say for example it was well, this one's 30 volts, so you would want that to dissipate over no more than maybe 15 or 20 seconds. You also then need to be careful that you don't use a resistor that's too low in value, that doesn't offer enough resistance, so a lot of the power will be lost to the resistor and it'll dissipate its heat. So what I'm going to do, this in this side, this little box here, there's just two capacitors, there's no bleed resistor, so I do need to put a second bleed resistor in here so that I can so that I can bleed off a bit quicker. I'm not terribly concerned about this because it's not a retail product. I'm not designing this for people to buy or for anyone else to use. It's for me to use above my workbench, so I don't actually need to put bleed resistors across it at all. But one thing I am concerned about, if I unplug this and I switch that on now, the voltage on the output here, because it's off load, that will rise, and it will rise right up to 50 volts because it's got nowhere to go. So we're at almost 51 volts and it's bobbing around very, very slightly, nothing to be concerned about. If I turn the power back off, okay, so the power's off now, and you can see it's bleeding very, very slowly. So we're now at 46 volts and 45.5 volts and dropping. If I was to plug that in to the LEDs, you'd get a voltage, a higher than rated voltage level running through the LEDs. Now it might not pop them immediately, but it'll certainly shorten their life, and that's not such a great thing, especially if you've got a poor connection, because that means that you would get some pretty significant transients going through the LEDs and you would just kill them pretty quickly. And there you are, we're a couple of minutes in now and we're still well above the rated voltage of the LEDs. So yeah, I do want to put a resistor in there to bring that down. Okay, so according to the capacitance resistor discharge table, if I use a 5k resistor, so I've got two 10k resistors here, and I'll put these across in parallel, so that'll give me an effective 5k, and it'll spread the heat dissipation across the two separate resistors. The power dissipation will be about 0.1 of a watt, so that's plenty, that's well within the value of these resistors. And my discharge time will be no more than 22 seconds. So I'm going to put these two resistors in series, connect back up the LED driver and give that a test, see what the outcome is.
Makes me wonder why people don't use them here in like hobby projects. I don't know how you're meant to program them, but I assume there must be fairly convenient methods to program them. And I assume they're very cheap microcontrollers. This one's got a ton of pins on it. It is that double wide package, though, which is a little bit annoying. Well, there's a couple there that look a little bit anemic.
Okay, I'll just pause my video. While I was soldering, I quite often watch other YouTube videos. I was just watching David Watts. David's I think he's at one of the universities down south, but he does a lot of build videos. He does kit builds, and he does his own, he designs his own circuit boards, he creates his own kits and he puts them out, he sells them online. So if you haven't seen David's videos, pop along and have a look. Okay, so this is ready. I've got my capacitors, I've got my two 10k resistors. Okay, you can see it's now much more rapidly falling away. So we're now down at 35 volts, and that's within a few seconds. So we're now at a safe voltage, so there's much less likelihood that anything destructive is going to get past that smoothing board or going to get into the LEDs and destroy my LEDs. So my lights are now switched on and they're mounted on the wall. I've cut down my shadows quite considerably. I've got no flicker that I can see. The bench is very bright. If I bring something right up to the camera, it's very bright, so I'm quite happy with that. I still do have these two washes of light, and if I just get rid of this, see, that's just because of the type of material I'm using here, this cutting mat. I'm not going to get away from that. No matter what I did, if I had these ones on, I had washes here. I've got spots on the ceiling, I've got washes down here. So that's always going to be the case. I would have to buy some professional photography equipment to get rid of that. So I think that's acceptable. If you disagree, let me know in the comments. Likewise, if you've got any suggestions or other solutions, then please let me know in the comments. It would be nice to get rid of these washes of light, but I don't think I'm going to be able to. So I'm quite happy with it. But if you do have any suggestions, please let me know. If you liked this video, or if you found anything in it useful, please give me a like and a subscribe, and I'll see you in the next video.